Thank you to those of you who have stuck with us this far and joining us for the roundtable session. Remember, if you have any questions, just stick them in the Q&A. And for this session, we are joined with a number of experts from the different projects. So I'd like to introduce or reintroduce some of them. We have Seyma Tarkan, who is the fish health expert, quality management and R&D team leader at Çamlı Feed and Animal Husbandry in Turkey. We have John Grant, who is the NSERC-Cooke Industrial Research Chair and Professor of Oceanography at Dalhousie University in Canada. We have Tamás Bardócz, AquaBioTech Group Project Coordinator of iFishIENCi project. We have João Gomes Ferreira, he's Chief Scientific Officer of Longline Environment Limited. We have Nikos Papandralakis from the Hellenic Center for Marine Research. And we have Frank Kane from the Marine Institute. He's the project coordinator of IMPAQT. So please, if all the members of the roundtable could just switch on your camera so we can see you. So because the Q&A has gone very quiet at the moment, I would like to kick off with some generic questions that we have pre-prepared. So I'd like to open the floor to our panelists to discuss what they see as the big drivers for the future direction of aquaculture and aquaculture monitoring, and how these precision aquaculture can play a role in that. Do we have any volunteers to jump in there? Well, I pick someone. John, would you have any ideas on this? Sorry, you're right in front of me there on the screen.
Sure. I'm happy to comment on that. Thank you for asking. Thank you for having me on the panel. And I'm a part of Kane as a North American partner, where we have done a lot of work, but we've also done this within what's called the Ocean Frontier Institute, which is a Canadian initiative and with international partners. I was really happy to watch the presentations today to see how far this has come in such a short time. And, you know, that really speaks to the priority that it has in European research, but also to the need, I think, from the industry, because if there was an uptake of the technology, it wouldn't, you wouldn't see this much progress. And I think that the drivers, you know, have to do with really sustainability and efficiency of production. I think we have several European programs, Horizon 2020 programs, that are stimulated by the potential to improve the economic efficiency of aquaculture, but also the sustainability with regard to understanding its interaction with the environment. So, I mean, there are certain specifics regarding, you know, advances that have come, but I was also very happy to see that the challenges of field aquaculture were met with a lot of results. So, you know, I'm a field guy and an oceanographer, and I always think that it's kind of harder to do in the field, but there's been a lot of progress.
Thank you, John. Like we see in recent years, particularly in Europe now, we have a lot of European regulations, environmental requirements on the aquaculture industry. We have water framework directives, we have marine environment directives, there's environmental impact assessments to be carried out. There's a whole variety of environmental monitoring that is required on the farms. So there's a big need for all this data collection and analysis. So do the panel feel that this is one key area that precision aquaculture can help for the future development of the industry, or are there other areas where precision aquaculture can assist as well? Tamás, do you have any comments on this?
Yes, I would go back for a second to the main drivers of the precision aquaculture, and I would like to bring here our example I am the coordinator of the iFishIENCi, but beside of that, I am also working for AquaBioTech, which is mainly involved in the recirculating aquaculture systems development. And on this field, what I see as a main driver is the growing interest for the land-based production of salmon. And for such system, there are two areas where the RAS systems has to be developed. And one is the reducing the risk of mass mortalities. And the other area is to reducing the production cost. And in both of these development areas, precision aquaculture and the development of precision aquaculture can help a lot. And I think these two things will be the main driver of developing precision systems, precision RAS systems or smart RAS systems in the future. At the same time, it's also important what you mentioned related to the environmental impacts of the aquaculture. It's also an issue for the RAS system because all RAS system has some effluent, and that's another area where precision aquaculture can support the RAS developments, the monitoring, continuous monitoring of the effluents, which also can support the reuse of this effluent. So not just providing information for the farmers and for the environmental authorities, but also can support the reuse and valorization of this valuable waste stream of the recirculating aquaculture. Thank you.
Thank you. Now we have a question in the Q&A for our IMPAQT colleagues. So maybe Seyma and Frank, how do you see the deployment of IMPAQT project pilots initiatives in South Mediterranean countries? What could be the challenges? And have you any perspective to expand IMPAQT with other pilots in other countries?
I might start that. So Neil, I was going to comment on the other one, but I'll come back to that. So within the IMPAQT project, we had 6 different pilot sites, and we very much made sure we covered the different environments. So we had the North Sea farms would have been an offshore seaweed farm. The Marine Institute would have been an inshore coastal farm. The SAMS would have been pretty much an mid-shore to coastal area. We had Çamlı, which would have been a Mediterranean industrial site. And then we had the Yellow Sea fisheries guys who would have been also inshore. So the idea behind the IMPAQT platform was that it's getting impact or input and feedback from a number of different producers and researchers so that the actual system should apply to pretty much most setups, including actually we had our freshwater site in Sligo in which we're doing perch and recirculating systems. So therefore we were hoping that it should be set up so that it covers everything. Sorry, I'll go back to the question. What are the challenges and what perspective for pilots within other countries? Yeah, the idea was that it's a system that covers all operating environments, and we were trying to consider all the different species. We had quite a diverse range of species between the pilots. The other angle was we were trying to make sure that we were covering not just fed species, which most current commercial systems really focus on fish. We were trying to make sure you can actually manage your seaweed and your non-fed species, either with or without fish within an IMTA setup, if it's that. So I don't know if maybe Seyma wanted to add anything on the Mediterranean perspective.
I think the IMTA system is working very well in the different conditions, including offshore. We don't expect to have these kinds of results in our offshore facility, as the nutrient dilution ways and the strength of the water currents. But I think it could be, but you need to design your system very well regarding to the structures, regarding to the hydrology of the plant. So I think most of the environmental conditions are beneficial, where the fish included in IMTA system, I think the nutrient is the most critical feature for these systems.
Can I make a couple of comments, Neil?
Yes, please. Yeah.
Okay, so the first thing I wanted to say was that, and I think that there's a difference between IMPAQT and what Kane has been trying to do. We didn't get too focused on the IMTA side of the work, partly because we were involved in a project that SAMS was leading on a few years ago called iDream. A good amount of the people that are involved in Kane were also involved in that. And the overarching conclusion for that in terms of the various trial sites in Europe was that you could typically grow different species together, but there wasn't a clear link. And I think in Canada, they found evidence as well that supports there wasn't really a clear link between the subsidy that was provided by the fish and the growth of the other species. And that was particularly obvious in the work that was carried out in the Eastern Mediterranean. There was a Cypriot partner, and there was great difficulty in actually getting anything to grow in the context of very oligotrophic waters, even with the fish subsidizing the process in terms of input of organic material. Nevertheless, one of the things that came out as a complementary advantage was that, for instance, in Norway, some of the people that we were working with were able to obtain licenses to co-cultivate different species. So the issue was there was more a leveraging of the space available, where there was a restriction in terms of what you could increase in terms of fish culture, rather than the fact that you were actually doing very well with an extra component there of organic contribution to helping, or inorganic for that matter, for the seaweeds, to help these other species to grow. So that was just a general comment on the sort of monoculture and IMTA component. But the other thing that I wanted to say was, in the context of the pilots discussion, was that in Kane, one of the initiatives that we have is something called the Affiliate Farm Program. And the idea there is that we are trying to demonstrate with our associate farmers industry that is involved in the project the advantages of having this kind of precision monitoring on the sensor side and on the response side, with respect to improving their understanding of how their farming business is occurring, and obviously leveraging that from both the profit and production point of view, and also from the sustainability point of view. But the idea of the Affiliate Farm Program is that we can, so it's a legacy concept, that we can demonstrate that to farmers that are interested, and sessions like this would be one of the ways of doing that, but of course there are many other ways. And the intent there is that farmers would then express an intent to participate. The cost to them would be essentially the cost of instrumentation, of getting sensors in place. The advantage to them, it's a bit like when you build a house and you hook yourself up to the grid. Of course, you need your own electrical infrastructure in the house to be able to do that. But then you have the advantage of a grid that's already set up. So the idea would be that from the marginal cost of getting sensors in place, they would get quite a lot of benefit from the tools that I see, and I've seen this morning, not just obviously in Kane, but in the other projects as well, have been developed that can then give them this kind of competitive advantage in terms of precision aquaculture.
Okay, thank you very much. We had a second question in the Q&A, but I think you may have answered a lot of that. Yeah, I see it's moved. Okay, so we have another one here. How can we mitigate the potential threats associated with increased reliance on sensors and technologies which may malfunction and measure incorrectly? Any of our panelists involved in the sensors would like to take this one?
I can comment on that. I mean, I think the answer to that is redundancy, really. We end up having, I mean, our sensors that are most widely deployed are temperature, oxygen, real-time sensors, and we find the need to have them in every cage, to have them at multiple depths, because they are commercially produced now for as fit for purpose. Then they are cost effective, and yes, occasionally they go down, or one has calibration issues, but generally the redundancy really can fix any of those kind of problems.
Thanks, John. We have a question in from Fergal.
If I may say something about that.
Yep, sure.
Even if I'm not a panelist, I think that redundancy plus quality control algorithm can do the job. And this is a point that I think should be stressed. All these platforms should be an efficient quality control system in place to avoid misuse of the data. And that's why some farmers, according to what I learned in the last 4 years, are not trusting this system, and they feel sometimes that it is more work to look at the data and to get information from the data than just trust their own experience, at least in some sectors of aquaculture which are not as mature, for example, as the salmon sector, and in particular in systems which are not as controllable as RAS systems.
Thank you, Roberto. Okay. I have a comment in from Fergal. I'll just read it out here. John mentioned the huge strides made in research and development related to precision aquaculture. So what are the perspectives of the panel on what is necessary to transition this research to commercial deployment? What has worked well in the past and what is different now, considering the multidisciplinary aspects of modern precision aquaculture farms, sensors, modeling, machine learning, etc.? We have any volunteers?
I just make a very quick and perhaps a little glib comment saying that the main thing in my view is actually producing things that people can use. Because very often what you see coming out of the research community, and that has happened occasionally this morning as well, and which is pitched as being intuitive and simple, to be quite honest, for your regular farmer, in some cases it's anything but.
Thank you.
I would just comment on that as well. I tend to agree. I think as researchers, one of our key aims should be to make sure we're focusing on the farmer, not on our research. We can come up with really great ideas and really good stuff, and we can create all this data, but unless it's actually focused on what the farmer wants at the end, it's pointless. But we also have the other sort of dual role of creating products for the farmer that they may not know they want yet. We had sort of the smartphone. We didn't know we needed a smartphone until we all got one, and now we can't do without them because it's so well designed and it's thought out. I think the key for researchers is we have to remember not the what we're producing, but more the why. The idea is the farmer wants to grow his stock, look after them, look after the environment, and do it all really efficiently. And we have to make sure that the product we're doing that is allowing him or her to do that really easily.
I would certainly agree with those comments that interface is critical. Accessibility for the farmers has been said, but what's in between the sensors and the interface are analytics, and certainly Fergal is well aware of that in his question, because we really need to translate that information into more advanced decision steps, and for that we need the farmers to tell us how they use the interface, what else they would like out of it. And I would say the predictability is really the, kind of the frontier of this whole thing. Yes, let's use the data as it comes in, especially in real time, but then that data becomes collated, becomes a fairly sizable data set. Now we have the ability to make predictions over a matter of days, and those can be critical in the decision making of the farmers.
Thank you.
Well, and I would just add that, you know, these discussions tend to get finfish focused, but we should bear in mind there's an awful lot more out there, and particularly if you're looking at the European Union, the component of bivalves is extremely important. It is in fact the majority of the production within the European Union, and it's more complex in various ways. John's mussels are naturally recruited down in the Algarve in Sagres Marisco, so that's not that easy to control, obviously. And of course, the food supply issues are completely different. So we should try and not, you know, leave parts behind as we move forward on this, even though I know it's a big challenge.
So do you see, is there there's obviously different requirements depending on the aquaculture sector. So you have the very highly advanced high-tech Norwegian salmon industry compared with, say, the fledgling seaweed industry. Their requirements would be quite different when it comes to data collection. So are we looking at developing different systems for the different sectors?
It's a very tricky question. I mean, clearly the salmon industry is at the forefront of this. I mean, even when you compare that to the bass and bream industry in the Mediterranean and elsewhere, that there's quite the gap in terms of the uptake of technology. But when it comes to shellfish, yeah, I think that, you know, when you're talking about concerns to do with chlorophyll, or as John Isley mentioned, with things like HABs and so on and so forth, it's a completely, I wouldn't say it's a different set of problems, but it's certainly a complementary set of problems that you have to factor in. And it, you know, definitely there are parameters that would interest a shellfish farmer that would not be, you know, high on the list of a finfish farmer.
We have one more question in the Q&A. Oh, sorry, Jesper raised a hand. Sorry, I can't see raised hands on my screen. Sorry. Jesper, do you have a question?
I have a couple of questions, or you can call them comments. You talk about different species than salmon and so on. Actually, shrimp has the value 2.5 times the value of salmon on the global scale. And if you go to the Southeast Asia, they are going into the most progressive companies are going into either biofloc or RAS systems. So to deliver smart farm systems for those are also interesting. I know it's outside Europe, but I'm working for a company that exports to the whole world. So we are looking into this. And back to the initial questions, what is the future for smart farm? I think that apart from reducing the feed spill, that is also reducing the costs, constantly automatically monitoring of the biomass in the tanks, and not less. And I think it's quite high on the political agenda, the fish behavior or the fish welfare. Consumer organizations are starting more and more arguing for documentation. We are in a dialogue with IKEA, and you think furnitures, but they actually have more than 1,100 restaurants around the world, and they are sourcing salmon from land-based systems, and they are asking desperately to have documentation for the fish welfare. And another issue is we need to be more circular. We can build RAS system in urban industrial areas, but we should make benefits of working together, using excess power or heat or whatever we need. So that's another issue that is high on the agenda. So, but that's we also need data, and I fully agree that the scientific results is very often overwhelming for the farmer. But today we actually built rather complicated RAS system, at least, and we need skilled personnel, and we are lacking behind education and training. So the more data we can present to assist the not so skilled workers to run the farm, the better. Thank you.
Thank you. I'll move to the Q&A question. We have a cheeky little question from Ola. Do you see problems with new young hacker farmers staying at the desktop, indirectly checking the farm instead of looking directly at the fish? Nikos, do you have any comment on that one?
I don't see any problem to this. Actually, this is going to be the future, especially if you go offshore, which is another way of farming. We're certainly going to need methods to operate the farm without the human presence. And taking this opportunity, I would like to point also out that apart from monitoring the environment, and I understand the importance for all the reasons that you and all the other colleagues have presented, it's also very important to the monitoring of the fish, of the individuals, and to monitor their behavior and to understand how they respond to our actions. And this is critical, not only for the husbandry practice, but also for the economics of the farms. And obviously, this is a big discussion. But I find it extremely interesting to point this out. And this match also with the question said before, are we going to develop different systems for different users? I think that in some cases, the species requirement are different, and we need to have either different systems or adapted systems to cover these requirements. So yeah, we have to look each part of the industry in a little separate way. This is how I think.
Thank you. Okay, we had another question there. I think that was answered. Tamás, you have a comment?
Yeah, I just wanted to comment that I fully agree with what Nikos said. And the question, I think it's actually a very interesting question. This brings in another aspects of the precision aquaculture, which is another problem of the aquaculture industry, that it's not attractive enough for the young generation. And precision aquaculture can bring in this into the aquaculture industry, that it became more attractive for young generations because it's more interesting, it's using more modern technologies. This is something, an added value of the precision aquaculture, I think.
Thank you. Okay, we don't have any questions in the Q&A. Maybe I have one maybe more general question before we wrap up. We now see the rollout of 5G technologies, and a lot of the systems are working on 3G or 4G. So I wonder, do our panelists see any potential benefits of this new 5G technology? Will it bring more advantages, or is it also worth developing systems that can still function effectively on 3G or 4G systems? Anyone want to come in on this one?
May I?
Yes.
Oh, okay. Actually, those communication technologies are very helpful for the sending data to the necessary systems. This is very important. As we see in our project, we analyze the 4G, 5G connection in the sites to sending the collected data from the sensors. So when we're moving off on the offshore conditions, you exactly need to sending data. So this is the very important tool, I think.
Yes, I agree.
Yeah, I would agree with that. And certainly, as we add sensors, as we add more sophisticated technology, the communication infrastructure is critical.
And I would like to say, add actually something else. The energy is another issue when you go to offshore. So we need to install the clean energy systems to the environment. While you are doing that, it is very important to analyze the daylight and conditions in the pilot sites or the aquaculture facility. So you can choose which energy supplement system to install to your system. Another critical one is the energy.
Okay, thank you very much, Seyma. Okay, we don't have anything in the Q&A. Before we wrap up, does anyone have any comments? Any more questions before we conclude? Okay, so that leaves it to me to say farewell to this Horizon4Aquaculture session and the series. This is obviously was the third session out of 3. I would like to thank all the participants who joined today and speakers who have attended and actively participated in this seminar, and also people who were involved in the previous ones. And we invite you to follow the development of these 3 projects. All 3 webinars will be shared on the various project websites over the coming weeks. So you will be able to log in and catch anything that you missed. So all I'll do is say goodbye and thanks very much for joining us. Thank you.